Composition of functions. So composition of function is just the process of using the output from another function as an input of another function. So as usually in our previous example, if you have a function uh, f of x, for instance, if you have a function f of x, we usually maybe substitute f of x is equal to maybe x plus 1. We usually substitute a number f of 2, we substitute 2, then we say 2 plus 1 and say this is 3. So in the composition, instead of substituting a value like 2, we will ask you that we have another function which is x squared. And instead of 2, here we want you to, the input to be this function. Input to be this function. So your input, we want it to be this g of x. So that's what we call a composition of a function. So we use this output, and this is just f of, instead of 2, then you have x squared. So which is the output of this function, then we are putting it as an input for f. So composition of function are used in mathematics in the forming using a simpler function to form a complex function. Let's give a real world example. But before that, let's look at the notation. So if we have a function f and g, their composition is denoted by this f and this small o and g. So f composite g, or we can say f after g of x. So and it's defined as, if you have f after g of x, is just f of g of x. So f with input g of x. So let's give a real world example. Suppose you want to fry egg. So I can define a function. First, I have a function f. This function is just break egg. It's just for you to break egg. And we have another function g, which is pour egg into pan. And we have another function h, fry egg. So if you look at all these are functions. This one is breaking, the f is breaking, g is pouring the egg, and h is frying the egg. So if I say, yeah, first, what I want to do is to break the egg, then I will have f of x, that is break the egg. But in this function, after I break the egg, what I want is to pour the egg. Then I can see g of f of x. That is g after f of x. So after breaking the egg, pour the egg. And after this, I want to fry the egg. Then I can see, then I want to perform h of this this egg that I pour. Then I want to fry it. Then g of f of x. So just something like, we can just call it fry. First, fry the poured broken egg. So f of x, you break the egg, g you pour it, and h you fry it. So this is just how we form a complex function in mathematics. So let's start with some mathematical example. You have a function f of x is equal to x squared and g of x is equal to x plus 1, and you are asked what is f of g. So the first thing to do is remember that f of g of x is just equal to f of g of x. Always remember this. So what we are asked to find is f of g of x. So we can say f of g of x is equal to our f. Now here the input is g of x. So instead of g of x, we just substitute x plus 1. Instead of g of x, we substitute what is g of x. G of x is x plus 1. We substitute that. And let's just remember that if we have f of x is equal to what? X squared. Remember, our f of x is equal to x squared, where this x is the input. And this x gives us this. This is x here, this is x here. And what we want to find now is f of x plus 1. So it is just like in a football. We have x here. Now we want to remove this x and substitute this x plus 1 in the function. Therefore, instead of x here, we substitute x plus 1 square. So instead of x, we substitute x plus 1. And this, if you like, we can expand it. So our f of x plus 1, and you know this is our f of g of x, is just equal to, if we expand this, x plus 1 square, and this is just x plus 1, x plus 1. And this is, if we expand it, x times x square, x times 1 plus x, 1 times x, which is just x plus x, 1 times 1, and is 1. So we'll have x square plus 2x plus 1. In this example, we have two function, f of x is equal to square root of x, and g of x is equal to x minus 3. And we want to find f after g and g after g of x. So let's start with the first one. F of g of x, let's always remember to write it as f of or f after g of x. So now we should remember, instead of this g of x in our f, if you look at in our f, we write it, instead of this g of x, we write what we have here, x minus 3. So f of x minus 3, this is our f of g of x. So after we write this, the next step is, let's write our f of x. Remember that our f of x is just whenever you put x, any input that you put, it will just take the square root of that input. So we put the input here x, and it take the square root of the input. But now what we want is, in our f of g of x is f of x minus 3. So in this case, our input is x minus 3. And if you remember this function, whenever it takes a value, it takes the square root of it. So here, instead of x, we write x minus 3. So we substitute this. Then that's all for this one. Then the next example is g of x, and this is just g after g of x. So g after g of x is just g of x. So what do we do? So instead of this g of x, we just substitute g. Instead of g of x, we substitute its value, which is just x minus 3. Then remember, let's write our g. Remember that our g of x is just equal to x minus 3. But now what we want to compute is this, g of x minus 3. If you look at here, our input is x here, and it's just say whatever our input is, we just subtract 3 from it. Here our input is x minus 3. So instead of this x here we just write x minus 3. That's our input. Then we have to subtract this 3. So we just replace this x with x minus 3. Since here is x, here is x minus 3, here is x, then this should be x minus 3. And this will just give you x minus 3 will give you minus 6.